Hi everyone, welcome to Cola Teaches Math. So today we're going to talk about polar area between two curves. And I have a question here and I'll show you how I teach it in class. So it says find the area, excuse me, of the common interior of polar graphs r equals 2 cosine theta and r equals 2 sine theta. Okay, so on the AP exam, you're not going to be expected to draw these crazy polar curves, but you could be expected to know what these two curves look like. And you have to know that 2 cosine theta is going to be symmetric about cosine symmetric about so we're going to jump out to 2 radius of 2. So let's just see how I can draw it. And I color coded it. Look at this iPad. And then 2 sine theta is going to be symmetric about the y-axis. So we're going to have this right here. Okay? All right, so it wants me to find the area of the common interior, which I will highlight in orange in here. It wants this area in here. So the first thing I tell my kids to do is why don't we set the two curves equal to each other to figure out where they intersect. So we're going to go ahead and do that over here. So we're going to have 2 cosine theta equals 2 sine theta. Divide out the 2 on both sides, and you're going to get cosine theta equals sine theta. And you have to be pretty good with trig. You have to know when sine and cosine are equal to each other. And if we're in the first quadrant, that's going to be theta equals pi over 4. So this ray right here in black makes an angle theta equals pi over 4. Okay, so first thing I tell my kids to do is we're going to shade underneath the ray. I can shade it in green so it stands out. And we're going to create an integral for the area of this green first. Oops, right in here. And the way you want to think about it is for the bounds, if you took your pencil and swept from x equals 0, and I think I should be able to do it. Let's do it in blue. So if I took this right here and I swept it from 0 to pi over 4, do you see how we would enclose the green region right there? Okay, so that's how I know my bounds for this first green integral are going to be, so this green area is going to be represented as 0 to pi over 4, 1/2. And now how do you know which curve to use? If you notice, this green region is touching the purple curve. So here's the purple curve up here. So we're going to do 2 sine theta squared d theta. Okay, plus in orange, let's create an integral for this orange area right there. So 1/2, once again, let's do my ray. If I'm going from pi over 4 to pi over 2, we sweep and enclose that entire orange area. So that's how I know my bounds are going to be, oopsies, pi over 4 to pi over 2. What color curve are we touching with the orange color? The blue. So it's going to be 2 cosine theta squared d theta. Sometimes you might have to just set it up. Sometimes you're going to have to solve it. So if you type that into your calculator, you should get 0.578. 0.5708. My apologies. Okay, so color coding is key.